determine the conduit fill capacity, you'll need to follow a few steps. Firstly, determine the cross-sectional area of the conduit. For a 24-inch PVC sleeve with an outside diameter of 2.375 inches, you need to subtract the wall thickness, which is 0.216 inches, to get the inside diameter. The calculation is 2.375 inches minus 2 times 0.216 inches, which equals 1.943 inches. Now calculate the inner cross-sectional area using the formula pi times the inside diameter divided by 2 squared. This equals 3.3 square inches. Secondly, calculate the area of the 12/2 Romex cable. The conductor area for 12 American wire gauge is 6,530 circular mils. The total conductor area for 2 conductors equals 2 times 6,530 circular mils, which is 13,060 circular mils. We will neglect the neutral conductor in this calculation for simplicity. Insulation area is estimated at 230 circular mils per conductor. The total insulated area equals 2 times the sum of 6,530 circular mils plus 230 circular mils, which totals 13,580 circular mils. Thirdly, calculate the conduit fill. The ratio of cable area to conduit area is 13,580 circular mils divided by 3.3 square inches. This equals 4,484 circular mils per square inch. The permissible fill is 60%. The maximum cable area per conduit is 0.6 times 3.3 square inches, which equals 1.82 square inches. Fourthly, calculate the maximum number of cables. The cross-sectional area of each cable is 13,580 circular mils, which equals 0.21 square inches. Therefore, the maximum number of cables is 1.82 square inches divided by 0.21 square inches, which is approximately 8.67. In conclusion, based on these calculations, you can fit approximately 8 cables into the 24-inch PVC sleeve while staying within the 60% conduit fill capacity. When calculating conduit fill, remember to always consult local and national electrical codes to ensure compliance with safety regulations. These calculations provide an estimate, and actual results may vary slightly depending on the specific Romex cable and conduit dimensions used. It's important to use accurate measurements and consider any other factors that may affect conduit fill, such as bends or fittings. Remember that exceeding the maximum fill capacity can lead to overheating and potential fire hazards, so it's crucial to stay within the recommended limits. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns about conduit fill calculations. The circular mil is a unit of area, equal to the area of a circle with a diameter of 1 mil, where a mil is 1/1000th of an inch. It is used to quantify the cross-sectional area of a wire. To convert from circular mils to square inches, you use the conversion factor. 1 circular mil equals 5.67 times 10 to the power of -7 square inches. Therefore, to convert 13,580 circular mils to square inches, you multiply 13,580 by 5.67 times 10 to the power of -7. This yields approximately 0.688 square inches. However, in the previous calculations, the value of 0.21 square inches was used as the cross-sectional area of each cable. This discrepancy may be due to the inclusion of additional factors in the 0.21 square inches value, such as the thickness of the cable jacket or the spacing between conductors. When performing conduit fill calculations, it's important to use accurate and consistent measurements for all components. If you are unsure about the appropriate values to use, consult with a qualified electrician or refer to the manufacturer's specifications for the Romex cable and conduit. In addition to the 60% fill capacity rule, there are other factors to consider when determining the maximum number of cables that can be installed in a conduit. These factors include the size and type of conduit, the number of bends in the conduit run, and the presence of other cables or conductors in the conduit. For example, if the conduit run has multiple bends, the maximum number of cables that can be installed may be reduced to allow for easier pulling and prevent damage to the cables. Similarly, if there are other cables or conductors in the conduit, the available space may be reduced, which would also affect the maximum number of cables that can be installed. It's important to carefully consider all of these factors when planning an electrical installation and to consult with a qualified electrician if you have any questions or concerns. Always prioritize safety and ensure that the installation complies with all applicable codes and regulations. Furthermore, it's worth noting that the National Electrical Code, or NEC, provides detailed guidelines for conduit fill and cable installations. The NEC specifies the maximum allowable fill percentages for different types of conduits and cables, as well as other requirements for safe and compliant installations. It's essential for electricians and other electrical professionals to be familiar with the NEC and to follow its guidelines when performing electrical work. The NEC is updated regularly to reflect changes in technology and industry best practices, so it's important to stay current with the latest edition. In addition to the NEC, local electrical codes may also apply to installations in certain jurisdictions. These local codes may have more stringent requirements than the NEC, so it's important to be aware of and comply with them. When in doubt, always consult with a qualified electrician or local electrical inspector to ensure that your installation meets all applicable codes and regulations. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. Always energize circuits before working on them, and use appropriate personal protective equipment such as gloves and eye protection. If you are not comfortable performing electrical work yourself, it's best to hire a qualified electrician to do the job. Also, consider the dirting factors that might apply based on the number of current carrying conductors in the conduit, as outlined in the NEC. When multiple current carrying conductors are bundled together in a conduit, the heat generated by each conductor can raise the overall temperature inside the conduit. This increased temperature can reduce the ampacity, or current carrying capacity, of the conductors. To compensate for this effect, the NEC requires that the ampacity of the conductors be derated based on the number of current carrying conductors in the conduit. The derating factors are specified in NEC Table 310.15 current. For example, if there are 4 to 6 current carrying conductors in a conduit, the ampacity of each conductor must be derated to 80% of its original value. If there are 7 to 9 current carrying conductors, the ampacity must be derated to 70%. The derating factors become more significant as the number of current carrying conductors increases. It's important to consider these derating factors when calculating the allowable fill capacity of a conduit, as they can significantly reduce the number of conductors that can be safely installed. To determine the number of current carrying conductors in a conduit, you need to count all of the conductors that carry current under normal operating conditions. This includes the ungrounded, or hot, conductors and the neutral conductor if it carries current. The equipment grounding conductor is not considered a current carrying conductor for derating purposes. In a 12/2 Romex cable, there are 2 current carrying conductors, the hot conductor and the neutral conductor. Therefore, if you are installing multiple 12/2 Romex cables in a conduit, you need to multiply the number of cables by 2 to determine the total number of current carrying conductors. For example, if you are installing 4 12/2 Romex cables in a conduit, there will be a total of 8 current carrying conductors. Based on the NEC derating factors, the ampacity of each conductor would need to be derated to 70% of its original value. This would significantly reduce the allowable fill capacity of the conduit. To avoid having to derate the ampacity of the conductors, you can use a larger conduit or install fewer cables in each conduit. Alternatively, you can use conductors with a higher temperature rating, which will allow them to carry more current without derating. It's important to carefully consider all of these factors when planning an electrical installation and to consult with a qualified electrician if you have any questions or concerns. In addition to derating, it's also important to consider the voltage drop in a circuit. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage of the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that the voltage drop in a branch circuit should not exceed 3%, and the voltage drop in a feeder circuit should not exceed 5%. To calculate the voltage drop in a circuit, you need to know the length of the circuit, the current flowing through the circuit, and the resistance of the conductors. The resistance of the conductors depends on their size, material, and temperature. You can use voltage drop calculators or consult with a qualified electrician to determine the appropriate conductor size for a given circuit. To minimize voltage drop, you can use larger conductors, shorten the length of the circuit, or increase the voltage at the source. It's also important to ensure that all connections are tight and corrosion-free, as loose or corroded connections can increase the resistance of the circuit and contribute to voltage drop. Voltage drop can be a particular concern in long circuits or circuits that carry a large amount of current. It's important to carefully consider voltage drop when designing an electrical installation and to take steps to minimize it. When running Romex cable through conduit, it's important to protect the cable from damage. Romex cable is not designed to be exposed to the elements or to be subject to physical stress. Conduit provides a protective barrier that can prevent damage to the cable from moisture, sunlight, abrasion, and impact. When installing Romex cable in conduit, it's important to use the proper fittings and connectors. Fittings should be designed to securely hold the cable in place and to prevent it from being pulled or damaged. The connector should be designed to provide a watertight seal to prevent moisture from entering the conduit. It's also important to avoid sharp bends in the conduit, as these can damage the cable. The NEC specifies the minimum bending radius for different types of conduit. When pulling Romex cable through conduit, it's important to use a lubricant to reduce friction. This will make it easier to pull the cable and will prevent it from being damaged. There are many different types of lubricants available, so it's important to choose one that is compatible with the cable and conduit materials. It's also important to avoid overfilling the conduit, as this can make it difficult to pull the cable and can damage the cable. The NEC specifies the maximum allowable fill percentage for different types of conduit. After the Romex cable has been pulled through the conduit, it's important to secure it properly. The cable should be supported at regular intervals to prevent it from sagging or being damaged. The support should be designed to hold the cable securely in place and to prevent it from being pulled or damaged. It's also important to ensure that the cable is not exposed to excessive heat or cold, as this can damage the cable. The NEC specifies the maximum allowable temperature for different types of cables.